Today we're gonna do another insane LeetCode solution, which took me multiple days to understand. But it is a group anagrams problem. And in the last solutions I saw before this in the roadmap, two-sum. Actually, we did a two-sum solution, but valid anagram was the one that didn't have an insane solution. I don't have an insane solution for a valid anagram yet, but there was an insane one I found for here. So typically, to solve group anagrams, you'd want to somehow turn an anagram as a key and, append matching strings to that key and then return that. Here it does the same thing, but the way it does it is the thing I noticed a lot with insane solutions is instead of using a lot of things from the standard library, especially the algorithms library, like using sort, they basically do it on their own. And in this case, they do it on their own, but the way they do it is just, how did they even think of this? I don't know how they can think of this. But first of all, I want you to take a notice in these numbers here. There are 26 total numbers here, okay? And there's 26 letters in the alphabet. And these are primes. And what they do is they get the product of multiplying the numbers together with the ASCII. And you know the problem if you're just trying to assign a number to a character and using the ASCII key to differentiate it. But the problem with that is different letters can add up to the same number as different letters. And that could give you bad results. That'll give you undesirable results. But here it fixes it using primes, which I'm not sure what it fully means yet. But yeah, and then there's the bottom part, which is similar to the beginning initiation in the first ever insane solution video, where there's a null pointer, so there's no the couts don't get immediately flushed, and then the sync with studio false makes it so this printf scanf isn't connected. The C streams aren't connected to the C++ streams, so that's not connected to cout or cin and all that. And then we have solution S, which it obviously gets from here solution, so a solution called S, and then it for every get line in the cin, which is basically the input, then it does it runs the method called func, right, in solution. And the couts here, you would think the cout would be be put out in the output, but that's not what's happening, because usually couts, the data from there gets put into the output, but what's happening is they're putting it in this thing called user.out, which is the same thing as the output right here. Actually, what I mean is, imagine this line didn't exist. When you do a cout, it usually goes to the cout zone. If we were doing cout in here, you would see a cout, and then you would see the prints. But they instead have the flow going to user.out, which is this part right here. So all the couts, instead of having to return, they just do a cout. And they basically build it from scratch. So there's this temporary right here that's able to divide and tell the difference between string groups. So this is like a group, for say, group, and then that is the temporary here is to separate them, really. And then this is the part where it creates the key to differentiate different anagrams, but still have the same anagrams grouped together in the same the same, say, array. And this part, it's almost like in, you know, if you were looking at Python in here and you would do dot values just to get rid of the keys and only have the values of it, so you can just have the array without the keys for the anagrams. This is similar to that, except it's I mean, yeah, this is basically just the same thing. It's just doing it a bit differently. With the data over here, that's the unordered map that's being created, and then it loops through it, obviously, and if it'll see out if first. I'm not sure why there's a boolean, to be honest. But yeah, that's what this code really does. Is, you know, all this optimization setups over here using cout and putting all the couts flowing to user.out instead of having to use returns, and they use a set numbers of primes, and that really saves on memory. I think in the original solutions they took a lot more memories. I did a lot of them, and this saves on a lot of memory, and it also is a lot faster because it doesn't have to calculate a lot compared to the other solution. And the other solution I was talking about, where the solution most people do is they do, okay, in Python they either have a count, use the ASCII of the character as a key, and then they, you know, use a tuple. Tuples, you can't change the values in tuples. You have to create it, and all you can do is read it, unless you read the values from a tuple, put it into a list, and then, you know, edit the list and put it into a new tuple. That's really the only way. But yeah, they append it to a tuple, or I mean in res or whatever. They append it to the array in res, and then it prints the values of it, which I was talking about earlier. And then or the other solution that most people do is they use an algorithm that's already built in to sort it, and then they put it all in the table. And in Python, I mean in C++, it's the same thing. We got the they create an unordered map, and then they loop through strings strs, and if the key, they define key, and then they sort it just like this solution over here. I tried recreating this Python solution in C++, but it was way slower than actually using the sorting algorithm in the standard library that this thing does. So if you're gonna do this in C++ in an interview, I suggest just doing this solution, not trying to recreate this first solution in Python. Unless you're using Python, I would do this solution. But in C++, I would only do this second solution, using this built-in algorithm like sort to sort it, and then you know, pushing it. And then this is just basically just making a whole like sort algorithm from scratch. So instead of doing sort, it does it on scratch in a totally different way, a way just built for solving grouping anagrams. So that's what this really does. I'm gonna leave a code in the description of the solution over here, but to be honest, I don't fully understand this solution. That's wrong. This solution is incredibly, like, I imagine my cursor as the runtime. It's hard to track what's even going on, just to even imagine or grasp in my head, like, where the runtime's cursor will be iterating through. So yeah, I get this part. Alright, that was in the first insane. I get this part. These are just so you can create unique keys without, you know, key collision, like with using definitions for characters with numbers, because then, you know, multiple characters can mean the same number as multiple other characters, and that can create problems for your solution. But this whole case thing is confusing me, because when I get rid of one of the cases, the whole thing breaks somehow. It might have to do with the default. I think I'm misunderstanding how Switch works. Other than that, I kind of get the whole gist of this. It just does the sort algorithm, but in a way just for grouping anagrams, and it uses these primes. I don't know how the hell they came up with this. They use these primes to make unique keys for the anagrams. But yeah, that's really cool. This is a really cool solution. If you'd like to take a look, I'm gonna leave a what's it called? I think it was called pastebin, a pastebin link in the description. I hope that just about explains it. It's very similar to the solution. It's similar to this solution, but instead of using the sort algorithm, it just uses its own algorithm just for grouping anagrams. So I said that 3 times now. But yeah, that's what this whole thing really does, simplifying it. But yeah, this is a really, really cool solution. I might make another video on it once I get further in a series and my understanding increases, and I'll be more in depth in that video compared to this one, because this is still really confusing me. But yeah, this is an incredibly intricate solution. Thanks for watching. Appreciate you guys.